Right click drag is this. Camera x-axis, horizontal shift, vertical shift. Wait, what? Oh, left click. I want the left click drag. Here. Man, that's complicated. Rotation off of the z-axis. And rotation around the z-axis. Okay, so I'm translating to the origin, rotating around the z-axis. Then I handle the rotation off the z-axis. Then I translate back. I remember this being some like pretty complicated code, but I'm only doing this top part. So first, wait, axis.add updater. So now I should be able to do self.camera.modelMatrix equals OpenGL. Something like this. X equals 0.01 times the same model matrix. Perfect. So that's doing what I expected to do. Okay. But I don't want to just move the camera. I want it to do basically this together with this. If I'm lucky, I can just put a small number here, comment this, and this will just do what I want. Perfect. This is exactly the ambient rotation I was looking for. What if I do DT here? It's a little better. Although this DT isn't that related to actual time. This isn't so complicated. This is just taking the camera's model matrix and translating it to the origin, rotating it around the z-axis, and then translating it back. So I make this slower. A lot slower. Yeah, that's kind of ambient rotation, right? Cool. Cool. Maybe a little slower. So what I want to do now is place some points in 3D space. And I want to show that when you apply the model view and projection matrices, they're rendered in Manim space. So I think it would actually be helpful to place some points, like points in 3D space. Or maybe a grid, like lines. I actually think seeing the points in 3D space would be more helpful. But to do that, I'll have to have either spheres or cubes. Maybe I can just take the geometry from 3JS. That might be what I end up doing. Let's see. Let me commit this first of all. This has been some pretty good progress. example.md tutorial.py example.md tutorial.py. Yeah, all of that stuff. Okay, I do have a way to get sphere geometry from OpenGL or from Three.js. Like this. Get geometry. So I don't even know if I can color it with my own shader, so I might have to get the material too. Wait, what's the defaults for this? Replace new mesh, was it? Geometry name, material name. What were the defaults? Oh, sphere and Fong. Okay, so I'm gonna basically try to copy this code. This should probably be factored into a library or something. So something like this. Get geometry and get material. I'm just gonna copy that verbatim. Okay, let me be less messy here and write a tutorial utils. Okay, this can have just get geometry and get material and get remesh. And this is where I'll put all those imports. I'm just gonna put all of this here. And then everything it tells me I don't need, I'm just gonna take out. I'll probably need that. No, I don't think so, actually. Space ops. Great. I do need the geometry stub, though. I need all of those. With that, I'll need gRPC. And that's where I need the service PB too. I was wondering where that came in. Okay. Then to get that mesh, I'll have to fill in the lights or whatever. I guess if I use a basic material, I won't have to do that. Material.shader, geometry.attributes. Okay, I'll see if I can just do this. Return a mesh, geometry.shader, or material.shader, geometry.attributes, indices equals whatever. The primitive will just be default. And for now, I'm just going to get the icosahedron. I can just import OpenGL.py. Well, this is an examples, a list of examples. Well, and these functions, even here, they're like inside another function and inside a class. So I'll do icosahedron. And I'll try doing the basic material. Okay, now if I import tutorial utils, and I don't expect this to work. Okay, now if I import tutorial utils, and I don't expect this to work. Let me say like thing mesh equals tutorial utils dot get remesh. I have basically zero faith that this will work. Wasn't trying to do that though. Self is not defined. That's true. I need a context. Let me just pass in the context when I do this. It's like render.context. And I can pass that into, I think, both of these. Does the mesh need it? No, it looks like it doesn't. Okay. No field of name normal. Why would that happen? Oh, I think I know why that would happen. Shader 55. Here, this is where it's filtering these. It's saying for data type name the unfiltered attributes. It's adding that to the filtered attributes, but it only wants to do that if dtype name is in attributes. Great. I have imported something. Now, yeah, I think that's fine. The color is kind of ugly. So let me not do the icosahedron. I'm gonna get a sphere. Nah, I guess I have to do this. Okay, that kind of looks like a point. Now, I could pass some parameters to Three.js to make the sphere smaller. Or I could multiply the model matrix. I think? Oh no, I can't do that. Because I don't know how to interface with the model matrix. Oh wait, no, I totally can. I can just do mesh.modelMatrix. OpenGL.scale matrix of like half. Perfect. I would like this to be a less annoying color though. Here's what I'll do. For range 0 to 5. For J, range also 0 to 5. Get a mesh, scale it down. Then mesh.model matrix equals OpenGL translation matrix. X equals I, Y equals J. Multiply by the mesh's model matrix. and then add it. Okay, so they're kind of too big. And I want this for like Z too. Also, yeah, this is fine. Also, yeah, this is fine. Well, what did I do? Indented block. Oh, yeah. Perfect. Except they're too big. So let's scale this down some more. It's weird that these are spinning. I feel like I have to center them around the origin. Yeah. So let me do like -3, 2, 4. Okay. I kind of feel like there's too many of them though. I think this is good though. Well, hold on, let me try -2 to 2. Yeah, that's probably fine. Or I could just do this in groups of 2. If I did this from like -5 to 5. And I skipped. I think this is how you do that. Yeah, that looks a little bit more comfortable. Okay, so this is the grid. This is ambient rotation. Grid. And now what I want to do is show that if you have a shader and you multiply the attributes by the model view and projection matrices, then they're moved into Manim space. Yeah, so this is where I want to add a mesh. Add a triangle or something. Position, color, V color. Yeah, this is all fine. I think this exact same shader is okay. Don't need that. Okay, I just had 3. Yeah, this is fine. And you just wanted to see what it looks like to go from -2, 3, 1. I'm just making up some numbers. 2, 5, -2, -4. Yeah, something like that. And the color, I'll just do green or something, or blue. I just make this into a mesh. Triangle. Okay, this should fall Okay, none of the corners falls on a point. So that's annoying. I feel like labeling these... Okay. Let me look at the numbers I chose. It's going from -5 to 5. I think I want it to start and end on even numbers, so I'll go from -6. I think I want it to start and end on even numbers, so I'll go from -6. The upper limit will be 7. Okay, then if I make all of the vertices even, so 4, 0, 0, 4, 6. Now it falls on these points. I picked pretty bad points though. I just wanted to illustrate that when you choose these points and you multiply them by the view and projection matrices, then they align, the points align perfectly on Manim's grid lines. Which I guess I did. You know what I should do? It should be possible to toggle this grid. That would be really helpful. If you could toggle this grid as well as toggle the endpoints of the triangle. Well, triangles don't have endpoints, I don't think, but the corners of the triangle, then I think that would illustrate this really well. So, I guess toggling the grid shouldn't be too hard, if I can remember how to do it. Show grid checkbox. The update show grid. Default value will be that show grid equals true. This takes sender and data. I still don't know what you could possibly do with... I don't know what you do with data at all. And all I know about sender is that you do dearpygui.core.getValue. Sender. I'll just make this self. I'll say self.showGrid equals that. Great. Why did that break? Show grid is not defined. Oh, this should be self. It would be really nice if this could recover from crashes. Like you could do something wrong, it would break, and you fix that and it automatically comes back. Maybe that's possible. I think that's possible. Okay, so I have a checkbox now. What I'm gonna do is... Where's the grid? Here. I'm gonna want to update a flag on these. So I have to do something like grid vertices. Grid vertices dot end mesh So I'll have to add mesh. And I guess I'll have to add an updater to these. Well, I guess not necessarily. I'm running into this spot where this spot with updaters where I'm oftentimes trying to update some or write some code in an updater where the updater doesn't really make sense attached to anything. Like, I guess I could just put an updater on the first one of the grid vertices. Or something like that. Like, I guess I could just put an updater on the first one of the grid vertices. Or something like that. We just have 0.add updater. Update appearance. Update rendering or something. And then sell, I forgot the name of the flag. What do I do for show object? Show object. Show object. Skip underscore render. I'd say mesh dot skip underscore render equals not show grid. Whoops. I don't know if you can even do not like that itself. Okay. So maybe there's one of these corners. Yeah, this one is disappearing. So what I want to do is for like point. Find the name of the grid. Self.grid vertices. Where is it? 4 point and self.grid vertices. Update it like that. And something broke. Grid vertices not defined. Yeah. Same thing, 323. Okay. So we got this. And now I can toggle it. And I think that's really helpful because it lets you can see the frame rate slow down when you add the dots. Which I guess makes sense. Really, these should probably be rendered with instance rendering. But I don't know how to do that, so yeah. But great. So next there should be sliders to control the endpoints of the triangle, or the corners. And then being able to drag that as well would be able to... That'd make this really, really clear, I think. Though I hope I can actually make that something configurable. Like, what would that require? I guess I could not pass in a position, and the position would just be determined by uniforms. And that's it. Would that work? Since there'd only be 3 points, I could just pass in whether it's the first point, the second point, or the third point, then pass in uniforms for the locations of the 3 points. So yeah, that would work. Okay, so let me try that. Vec3 first point position. Yeah. So that should still work.